What's up, everybody? This is Coach Sharp. Welcome back to my Algebra 2 / Advanced Algebra note videos. Um, this video is going to be our notes that we've done in class this week, the week of November 11th through the 15th, 2024. You know, whatever we do this in the future too, obviously. It is solving equations using logarithms. We went over some different examples very quickly in class, different things we can do with logarithms. But the main thing that we focused on, we're going back to those real world exponential functions. And the main thing we're going to do now is instead of you start with this interest rate this long, what do you end with? You start with this interest rate, this is what you end with. How long did it take to get there? And we're going to use logarithms to help us do that. All right, let me share this. Got my head minimized now. I'll put my glasses back on in a second so I can actually see. That was not what I wanted. There we go. And actually move my head up here in this corner. I think I can move this way. All right. Now I put my glasses back on. There's a little bit of glare on my glasses. Again, y'all should be looking at the main part of the screen anyway. So solving equations using logarithms. Told y'all in class, this is one of those examples of notes I've mentioned a few times this year now where it's just going to be, we're solving an equation. So it's going to be straight. I give y'all steps to solve the equation, and then we do some examples. And so here on the next page, now I need to move my head again because it's blocking. Kind of right here. Got the 5 steps. Although, if you remember from class, we didn't really do any where there were 5. If we'd have been step 5, we would have been doing a compound interest or continuous compounding problem where we were trying to figure out time, which was possible, but just, elected to keep it kind of basic. So steps 1 and 2 should kind of be your hint. Divide both sides by p, simplify 1 plus r / 1 minus r. So we're just going to be going back and using the regular growth and decay formulas. A equals P times 1 plus R to the T power. A equals P times 1 minus R to the T power. After we do both of those first 2 steps, over here on the side, my equation, this shows what my equations should look like. They should look like our base exponential function that we talked about at the beginning of the unit, but just the sides are flipped because of the commutative property. You'll kind of see it in this first example in a second. After these first 2 steps, when we get this, then we can still do the relationship. I'm doing it up and down. You do it up and down or side to side. Let's see how I can make this work because I don't have my little board thing in my pen. Log base B, it's supposed to be a B, of Y equals X. So BX and Y are going to be the same. We turn it into a log. Then we can take that logarithm and calculate the value for it. We're going to use the change of base formula that we talked about, turn into that fraction log Y over log B. You can punch that in the calculator and solve. Again, pause it if you need to write this down. If you didn't get it, I'm trying not to make the video too long, so I'm going to go ahead and move on. All right, first problem. I did a real world-ish example, I asked one of your first period or I asked first period if any of them were currently saving up for anything, and one of them said what they were saving up for. Dakota wants to buy a new lift for his truck. He currently has $700. The lift costs let's put that up. The lift costs $1,500. How many months will it take to grow if he earns 2% of interest a month? So I started off this as a real world example. I turned it into an equation. Y'all see how we work it out. You're not quite going to get a problem like this on homework or on your test, but we can still work with the equation. Okay. So as we're reading through the problem, we're going to do the same thing we did with the other growth and decay problems. We got to figure out if it's growth or decay, what variables I have to fill in, and then what's the one variable that I'm looking for. So wants to buy a new lift. He currently has $700. Beginning amount, principal, however you want to, if it's money in particular, that's our P. The lift costs $1,500. How many months will it take to grow if he earns 2% interest a month? While this doesn't explicitly say how long will it take for the account to grow to $1,500, that's what we're assuming that we wanted to grow to so that you can then go buy the lift. So we know that this is going to be our final amount. A. How many months? So this is where, again, a little intuition would probably help. We have $700. We want to buy something that costs $1,500. So this isn't going to be a super long-term investment, hopefully. So we're not going to invest money in talking about how much is it worth years down the line. Hopefully. I'll see why I'm saying hopefully in a second. So, we're kind of looking at months because, if it gets too much longer than that, we'll talk about what that means. How many months will it take to grow if he earns 2% interest a month? So that's going to be your R. Okay. 2% interest a month. We're looking for months that matches up. Again, if you expand this out to a year, when you get compounding involved, it's actually going to be more than 24% interest a year, but you just did 2% a month times 12, it's 24% interest. That's what you're earning. We talked about in class, talked about with the compound interest problems a few weeks ago when I talked about my public stock. 16% is probably unrealistic for a investment. So 24% is probably even more unrealistic in terms of investment. Now, most of your credit cards are actually going to be around that. That's actually what your interest rate you get charged on a lot of credit cards. That's roughly what it is. All right. So I've got A, P, and P, R. We're looking for how many months, which means we're looking for T. I did not fill that in. All right. Up the top, y'all notice that. Again, it's the regular growth, regular decay formulas I mentioned. Other thing I forgot to underline, how long will it take to grow? Grow, increase, exponential growth. Even if it didn't explicitly have the word grow, we're starting at 700, trying to get to 1,500. So obviously we're trying to get more. Okay. So here's our equation. A couple people I saw already doing their homework, did the extra step like I did on the growth and decay problems. You wrote, I was trying not to do this because it's going to take me a little longer since I don't have my pen. I'll use 1 plus R. Well, it is going to be 1 plus R since it's growth. They were writing the formula that they're using. Then filling in what AP and R are, or writing out what AP and R are. 1500, 700. I promise that's a 7. I'm trying to do this with my finger. That's 700. I promise. I hope you're listening without uh, sound. That's 700. I guess maybe just in case you're not. Let me go back and try to make that somewhat legible. And then R is still a percentage, so we still have to move that decimal 1, 2 spots to the left. It's going to be 0.02. A lot of people are still messing that up. 0.02. All right. Sorry. Then you got one there. So if you want to do that, if you need that extra step, you can. But I was just going ahead and jumping to where it's filled in, which is what we got right here. 1500 equals 700 divided by 1 plus 0.02 to the t power. I'm going to do what I did in class. I'm going to follow the steps, and I'm going to use different colors. So step 1 was to divide by p. So I'm going to divide both sides by 700. Okay. 700 and 700 here are going to cancel, leaving me 1 plus, and myself, 0.02 to the t power. Then on the right, you can divide 1500 by 700. You can actually do that in your calculator. You can chop off the shared zeros and get 15 divided by 7. You want to punch it in that way, but I know off the top of my head that's 2.143. 2.143. All right, step 2 is to simplify 1 plus r or 1 minus r. What's in parentheses? Plus is a little easier. You're literally just going to stick the 1 in front of your decimal. So 1.02 to the t power. And 2.143 comes down. All right. So pointed out on the last slide, this now looks like y equals b to the x power. 2.143 is y, 1.02 is b, and t is my x. So if I turn that into a log base b y equals t. Okay. 1.02 is going to go to be the base of the log. I just think I figured out what I'm going to do, by the way. So log 1.02, since my finger's not working. Not like that. My screen is touch. I always forget that. All right. It's touch screen. I'm gonna do that. It might not look a ton better, but one log base 1.02 of 2.143 equals t. Oh yeah, it looks a lot better. All right. So now I've turned it into a log, and now what I'm going to do is use the change of base formula. The regular size number goes in the numerator. 2.143. I promise that's a 3. The base goes in the denominator. Okay. Now, showing you how to punch this in the scientific calculator. Log 2.143 divided by log 1.02. That's what you would punch in, and you would get T is, I don't know off the top of my head. Use my phone calculator real quick. $38.49 years. Okay. 38.49, or excuse me, not years, it was months. Back up, sorry, it was months. 38.49 months. So 38 and a half months, basically. Okay. Um, if we go back to the original premise of the problem, if we took this $700 and set it aside as an investment, again, I told you we're roughly getting 24% interest a year, which again is impossible in real life. But even at such a high interest rate, we're slightly doubling our money from 700 to $1,500. I mentioned in most of the classes, if not all, I don't want to go too deep on into it. The principle, it's not a principle, but excuse me, the concept of the rule of 72, which y'all may hear about in econ next year, or if y'all are business majors in college. It's basically how many years will it take for your money and investment to double. You divide the number 72 by your interest rate. So 72 divided by 24% interest over the course of a year, if this is 2% a month. 72 divided by 24 is 3 on the dot. So if it had been 1,400 instead of 1,500, we'd been looking right at 3 years, but we're going slightly above double. Okay. Again, Dakota's not going to wait around over 3 years for this money to grow $800 more to get his lift. He might not even have the same truck at that point. So in a situation like this, he would probably, just try to save up the extra 800 and purchase it. A situation, let me actually get it back where y'all can see me. Where did I put it? Okay, I don't know where I put my head. It says I'm screen sharing. All right, I don't know where my head went. Anyway, a situation that a real life situation I said in class where something like this might make more sense and roughly the same amount of money. If when you have a family and you got kids, you got young kids that you want to try to save early on for something they won't need for several years. What I said was a car. If you got two kids that are, 2 or 3 years apart in age, when they get old enough to drive, they're going to want cars, and you're probably going cheap used car to start with for both of them. But you can make it even easier on yourself if you can put aside some money when they're younger and let it grow for 6, 8, 10-ish years, kind of depending on how early you plan that out. Um, if it takes your money a little over 3 years to double, it would take a little over 3 years again for 1,500 to double to 3,000. So if you look at it that way, maybe roughly 6.5 years or so for 700 to grow to 3,000. So in a situation like that, if you put aside $700 when Dakota was 9 or 10 years old, suddenly when he turns 15, 16 years old, he'll have $3,000 to, either get a very, very cheap used car, or a down payment for a decent used car, something like that. So there might be a situation where a problem similar to this would make more sense instead of him just trying to save up $800 for something he wants in the short term. All right. Next slide. Next problem. I'm just gonna do this one. The last two that we did in class, the video that's already in the assignment, I'll leave it up there. It's similar problems with Boomtown and Leave Town, the population growing and condensing. The two problems in this video and your notes are basically verbatim from the previous growth and decay worksheet y'all had. The video that's already up there is the same problems, but I just flipped the number. I changed some of the numbers. But let's take this problem real quick. Again, I wasn't trying to make this super duper long. A radioactive element decays at 5% annually. This also came from the growth and decay worksheet that y'all had, the one where I scratched out some of the problems. This was number 9. Y'all did one of the two parts of number 9. You had the radioactive element decaying at 5% annually, starting at 40 grams. And y'all figured out how long it would take, or how much substance would be left after 30 years. I think that's what it was. And got 8.6 grams. The other question said, how long would it take for the substance to drop below 20 grams? So I tweaked the wording based on what they were asking, and they're still, we're still calculating the same thing. It was honestly something I thought y'all had seen in science class previously. What is the half-life of the element? So that is a science thing. We're bringing in science into this. Half-life is pretty self-explanatory. How long does it take for my element to lose half of its mass from when you started measuring? Again, it might not be the original mass, because if you're measuring over periods of time, longer periods of time, if you started with 40, but you're trying to figure out how long it would take to drop to 5 grams, you would be doing half-life 3 times, from 20 to 10 to 5. So whatever amount you had when you originally are starting measuring, how long does it take for your material to drop down to half of that? So reading this problem, radioactive, click on the arrow, that's the problem. There we go. Radioactive element decays at 5% annually. You got decays, means we're doing decay. 5% is still R. Move the decimal 2 spots if you need to. 1, 2, 0.05. You start with 40 grams P. What is the half-life? So I know I'm looking for T, and I'm looking for T when P is cut in half. So then my A is going to be 20 grams. Y'all have to know what half-life means. There's going to be a half-life question on the test. I messed that up twice. I look like grams for a minute instead of grams. There you go. So P is 40, A is 20, R is 0.05. What is T? All right, so here it is. 20 equals 40. 1 minus 0.05 to the T power. First thing, divide both sides by 40. If we actually, I prefer y'all to get the decimal. It's going to be easier, which is 0.5. And y'all know that's a half anyway, but even if y'all say that's a half, it doesn't necessarily translate in some of y'all's heads like the fraction does. 1 minus 0.05 to the T power. If we simplify this fraction, cut the zeros off, you got 2/4, which simplifies to literally, that's not what I'm doing. Too close to the edge, apparently. 1/2. So half-life makes sense. All right, so 0.5 equals 1 minus 0.05 to the T power. Simplify that. 0.5 equals 0.95 to the t power. No. Exponential form, y equals b to the x power. Change to log base b of y equals x. So we get log base 0.95 of 0.5 equals t. Change it with the change of base form. Log 0.5 divided by log of 0.95. So I wanted to make a quick note, and y'all see it on the second problem from the other video when we're doing leaf count, the population going down. So most times when we have a decay problem, it's going to wind up happening is you're going to get two decimals that go into your log that are both less than 1. If we look at the previous problem, you had 2.143, 1.02. They're both greater than 1, so the bigger number wound up being in the numerator, smaller in the denominator. But it's not just the bigger goes up top, smaller goes in the bottom. It's where their placement is here. 2.143 is the regular size number. That goes in the numerator. 1.02 is the base. It's supposed to look smaller. I know I didn't really make it look smaller, but that's what goes in the denominator. This problem, 0.5 is the regular size number, so it goes in the numerator. 0.95 is the base, so it goes in the denominator. So it's the positioning within the logarithm. It's not which number itself has a greater or less value. Because if you look at these, 0.95 actually has a greater value. It's closer to 1 than 0.5 is. So if you were judging it based off that, you would have 0.5 in the 0.95 in the numerator, 0.5 in the denominator, which would be incorrect. All right, so that's going to give you your C. You punch it in the calculator, log 0.5 divided by log 0.95. And if you do that, your T is going to believe, what was this one? I want to say it was 13 point something years. Oh, yeah, can do that. 13.51 years. Okay. 13.51 years. But what you need to do is this one, you honestly have a little more leeway in terms of saying 13.51 years, but when you've got a kind of a regular growth or decay, this or population, it's going to want you to round up to the next whole year, 14 years. It's not just because this is 51. Even if this was lower, like 13.21, and we rounded down to 13. Okay, so we were saying 13 years instead of 14. The way to check this problem would be to go back and plug in 13 right here and see if I get 20 or lower over here. So if I drop it down to 13, and it's saying at the end of 13 years, has my substance dropped below 20 grams, which hopefully y'all realize it has not at the end of 20 years. What did I say? 13. What's that? So 13 years, I said 20 years. 20 grams. I'm sorry. 1.05 to the 13th power, 40 out in front. What is A? If you calculate that, that is going to be 0.95 to the 13th power times 40. So at the end of the 13th year, you would actually have 20.53 grams, which is still above 20. So that's why you would say during the 14th years when it dropped below 20 grams. You'll do that for population as well. So, I can't make any promises and it's not a trick, especially because I'm telling you all up front. But for a problem like this, your four answer choices might be 12 years, 13 years, 14 years, 15 years. And you'll have to pick 14 to get it correct, not 13. All right. That video still took a little longer than I wanted. I apologize. I'm getting this off for one more minute. So at least cut the glare down here, even if you still see it up here. Um, Again, those two examples out of the way. Make sure you know what half-life is. If you want to go watch the other video to get population examples of population growth and decay, I will leave that video linked in the assignment as well. So, if y'all got any questions while working on this worksheet, as usual, message me and remind. Go back and start going over stuff for your test because we are testing next week before break. So until then, and until the next video, I'll see y'all in class.